Alright guys, so in class we learned some cool stuff about trig and transformations. We learned about the stretching and amplitudes and the shifting and the principal axis and the squishing and the stretching and the period and lots of really cool stuff. But right now we're going to do a good problem. We're going to do one that puts all of that stuff together. And we're going to talk about what we're going to do in what order and why. Alright, so first let's go through and consider each of the pieces here. Okay, I've got a 2 in front. My parent function obviously is sine of x. Now the 2 in front is outside of the function. Being outside of the function, that means it's going to affect y, and it's going to do exactly what it says. This is a 2 times the sine of x, so this is going to be 2 times the y values. We also talked about in class that the number in front that's causing the y values to be multiplied is also going to be our amplitude. Alright, let's move on to the next number. We move on to the next number right here, which is this 2. That 2 is now inside the function, right? Because it's inside of the sine x. Now because of that, that means it's going to affect the x. Now if it affects x, it does the opposite. So instead of multiplying the x values by 2, it's going to half the x values. And we talked about earlier in class that then meant that it was going to half the x values and therefore half the period. Now remember, this is not the same thing as the amplitude, where the 2 is the amplitude. This is somehow related. So actually what it's going to be is that the period equals 2 pi over b. Now this number right here is the b, and I'll give you the format in just a minute. But so that b is right there. So we're going to take the 2 pi and divide by 2, which means that the new period is pi, which makes sense because it's half of what it used to be. Alright, we'll move on to the next one. Now we've got a plus pi over 2. Again, that's inside the function. It's being done directly to the x. Anything done directly to x is the opposite. So instead of adding pi over 2, I'm going to subtract pi over 2 from all of my x values. And then I've got the last piece right here, the plus 2. Now that is outside of the sine of x. That's outside of the function, which means it's being done to y. And if it's being done to y, it's exactly what it says. And so therefore, this is y needs to be added to 2, which again is my principal axis. Okay, so let's go ahead and we're going to take 10 seconds to draw what the graph originally looks like, which is like this. And we go from 1 to -1, and then we've got pi over 2, we've got pi, we've got 3 pi over 2, and we've got 2 pi. And so we go 0, pi over 2, pi, -3 pi over 2, 2 pi. Ooh, that doesn't look like it's in the right spot. Good thing this is a tablet. I can fix that really quickly. And then my graph looks something like this. All right? It's not perfect, but it's pretty nice. All right, so now I need to do each of these things. Now, the interesting thing is that the x and y don't affect each other. I can look at the y's and I can look at the x's individually, and they won't hurt each other. So what I'm going to do is anytime you look at a variable, you'll do the stretching first, and then you'll do the shifting. All right, so first I'm going to do the amplitude. So now the amplitude means that it needs to be stretched by 2. So it's going to go up to 2 and down to -2. So that means it's going to go up like this. So I'm doing the y values first. And then it goes down to -2 and then up. Okay, and then it needs to be, so that's the first part of the y. The second part of the y is that it needs to be shifted up 2 spaces. So that means the principal axis, which was here at 0, now needs to be shifted up to 2. So my new principal axis is going to be up here. Everything needs to shift up 2 spaces, 1, 2. The amplitude still needs to be 2, which means I'm going to have to go all the way up to 4 here. So up to there. Again, this is still pi over 2. I haven't affected the x values at all. They're still where they used to be. That one down here needs to go up 1, 2, and then there. Okay, so I'm just kind of going piece by piece. First thing I did was I stretched it, multiplied each of the y values by 2. So the 1 went up to the 2, the negative 1 went down to the negative 2, the 0 stayed the same. So I did this first, check, and then I went over and I did the principal axis. I shifted everything up 2 spaces, and so everything moved up 2 spaces. This was at 0, went up 2. This was at 2, so it went up 2. 0 up 2, negative 2 up 2 to 0, and so on and so forth. So now you see I have the stretch. I also have the shift up, and so now I'll look at the x values. Again, I'll do the stretch or squish first, which is halving the period. Now that means that each of these values needs to move in by half. So that needs to move there. This one at pi needs to move into pi over 2. This one at 3 pi over 2 needs to move in. This one at 2 pi needs to move into pi, because 2 pi divided by 2 is pi, which is going to give me this graph right here. Now this is starting to get a little bit messy, but you can see where these things are coming from. And so then that's just the first part. I need to repeat it again. That was halfway in between, so again, that was halfway in between the 0 and the pi over 2. By the time I got to pi over 2, it was back to 0 again right there. And then I go down to the x-axis in between those two, and then by the time I get to pi, 2 pi, I'm back. And so there we go. You can now see I've done 3 of the 4 transformations now, right? Because I've done the stretch. My amplitude is still 2. I did the shift. My principal axis is still up here at positive 2. And then I did the squish, which was this 2 right here, to make the amplitude, or sorry, the period equal to pi. And so the last step now, I need to shift everything. It says x plus pi over 2, so I need it to move it to the left pi over 2. So I'm going to take each of these values, and I'm going to move it to the left pi over 2, which means I need to create a new, let's go negative pi over 2, just so I can have it. So this point here, it's now the green graph I'm shifting over. This one moves there. This one moves there. This one over, pi over 2. This one moves there. This one moves there. Everything's just shifting to the left, right? This one there, and this one there. And so you can see if I create that, I've got a graph that goes up and down. And this is actually my final graph, so I guess I can do it a little bit darker. Okay. And then right there, and back to 0. Okay, so now you can see that not only did my graph stretch, it still has an amplitude of 2. It still has a principal axis of 2. It has a period, right? If I check the period from any point to another, so from here to there, the period is still pi because it was halved because of the 2 in front. Plus, the sine curve, which used to start at 0, is now starting at negative pi over 2, which means it's been shifted to the left, pi over 2. So there you go. That's the whole graph. Now, if you want to see what this looks like without all the other lines, we can get rid of them pretty easily. We just go do-do-do-do-do-do-do-do. Do-do-do-do-do-do-do-do. Oops, there it went. Do-do-do-do-do-do-do-do-do. To get rid of all those. And I got to put that one back in. And so there you go. So that's what my sine graph looks like. You can still see my principal axis, amplitude, everything is there. So I hope that's helpful. Again, recognize we did the y's first, then we did the x's. You don't have to do that, but I find that doing this horizontal shift last is usually simplifies things. So I do the y's first, then I do the x squish. I always do the squish before the shift because multiplication comes before addition in PEMDAS. So y's first, stretch and then shift, and then do the x's, stretch and then shift. Now, in conclusion, what you'll usually see is something like this: y equals a sine of b times x plus c plus d, or sometimes this will be minus c right here. It just depends on which one, what type of thing you're looking at. But again, the a is the amplitude, the d is the principal axis, the b is not the period, but it is related to the period, 2 pi over b, and then c, of course, is just that horizontal shift. Since that's the least related to a specific point on the graph, that's one of the reasons why we do it last. So, hope that's helpful as you go through your homework tonight. This was a good problem, wasn't it? Good luck!